electron gain enthalpy. Just as energy is required to remove an electron from an atom, similarly energy is released when electron is added to a neutral atom. This is called as electron gain enthalpy. So we can define electron gain enthalpy as the energy released when electron is added to an isolated gaseous atom to form the gaseous negative ions. Now the factors on which electron gain enthalpy depends. The first factor is nuclear charge. So greater the nuclear charge, greater will be the attraction for the incoming electron. So the electron gain enthalpy becomes more negative as the nuclear charge increases. Then size of the atom. When the size of the atom is large, the electron gain enthalpy becomes less negative because with the increase in the size of the atom, the distance between the nucleus and the incoming electron increases, and this results in lesser attraction. Then the third factor on which electron gain enthalpy depends is the electronic configurations. Now, we know that half-filled and fully filled orbitals are more stable, so they have less tendency to accept the additional electron, and so electron gain enthalpies, they are less negative. Now let us understand the periodic trends of electron gain enthalpy. First, I would like to discuss about variation down a group. When we move down a group, the size and the nuclear charge increases, but the effect of increase in size is much more than that of nuclear charge, and so the additional electron feels less attraction by the large atom. So the electron gain enthalpy, it becomes less negative, right? Then we can see this from the table. We can see fluorine, chlorine, bromine, and we see that there is a decrease of electron gain enthalpy in going from chlorine to bromine to iodine. Then we come to the variation along a period. When we move across a period, the size of the atom decreases, and so the nuclear charge increases. So both these factors, they result in greater attraction for the incoming electrons. Therefore, electron gain enthalpy becomes more negative in a period from left to right. So again, when we move across a group, then what happens? The electron gain enthalpy value becomes less negative, and when we move along a period, that is move from left to right, then electron gain enthalpy value becomes more negative, right? So it becomes more negative. Then we come to important trends in electron gain enthalpy. See, the halogens, which is your group 17, they have the highest electron gain enthalpy. The reason why they have highly negative value of the electron gain enthalpy, because their electronic configuration is ns2np5, and they just need one electron to attain the stable noble gas configuration. So they have strong tendency to accept an electron, and so their electron gain enthalpy values are highly negative. Then electron gain enthalpy value of noble gases, they are positive, right? So why they are positive? Because the noble gases have they have stable electronic configuration, and so they have no tendency to take an additional electron. So this means that incoming electron enters the next higher level and does not feel any attraction for the nucleus. So energy is required to force that electron in their atoms, and so the electron gain enthalpy values are positive. Then the electron gain enthalpy value, you can see here, for fluorine is less than that of chlorine, and then it decreases. Now the reason why electron gain enthalpy value for fluorine is less, because as the electron enters, the size of the fluorine is very small, and as the electron enters, it suffers repulsions. So as a consequence of small size of fluorine atom, there are strong electronic repulsions in the relatively compact 2p subshell of fluorine, and thus incoming electron does not feel much attraction.